So this is a continuation of section 4.3. In this video, we are going to be talking about inverse trig functions. Inverse trig functions are what we use to solve for unknown angles in a right triangle. So the inverse trig functions are sine to the -1 or sine inverse, cosine inverse, and tangent inverse. And so we use these when we don't know the angle and we have two of the sides. So here we have an example. Use inverse trig functions to solve for x and y. So as you can see, we are solving for angles. So that would require us to use the inverse trig functions to solve. So our first step is always going to be to set up whatever the trig ratios are. So we have two sides. So looking just at this angle x, 23 would be the side opposite because that's across from x, and 31 would be the side adjacent to x. So since we have opposite and adjacent, we would use tangent of x because the angle always goes next to the trig function, and that equals opposite over adjacent, so 23 over 31. If we look at y now, angle y down here, now my opposite side is 31 and my adjacent side is 23. We still have opposite and adjacent, so therefore we are going to be using the tangent function. So the tangent of angle y equals 31 over 23. Our next step is we want to use the trig functions to solve for the angle. So on our calculator, the inverse trig functions are second sine if you wanted sine inverse, second cosine if you wanted cosine inverse, and second tangent if you wanted tangent inverse. So tan inverse of 23 divided by 31, when you plug that into your calculator, so second tan 23 divided by 31, you should get 36.57, and this would be degrees. So make sure that your calculator is in degree mode so that you get the correct answer and you're not doing it in radians. For my second equation, I would get tan inverse of 31 over 23 equals y. And here I get 53.43 degrees. So once again, you need to be in degree mode for this to work. And these are the two measures of my angles. So here now I have a word problem. A historic lighthouse is 200 yards from a bike path along the edge of a lake. So here is that. A walkway to the lighthouse is 400 yards long. Find the acute angle between the bike path and the walkway as illustrated in this figure. So here I have an angle. I have this side, which is my hypotenuse. It's across from the 90 degree. And I have this side, which is opposite my angle. So I have opposite and hypotenuse. So when I set up my trig function, I'm going to use sine because if we think of SOHCAHTOA, sine goes with opposite over hypotenuse. So I'm going to write sine of the angle equals my opposite side, which is 200, over the hypotenuse, which is 400. So now that I set up my ratio, I need to use inverse trig. So finding sine inverse of 200 divided by 400. And this is theta equals. So that is what my angle equals. So when I go to my calculator and plug that in, sine inverse 200 over 400, I get theta equals 30 degrees. And I'm done with that. So the last thing is trig identities. So we have a bunch of different identities that work for these trig ratios. So the first are the reciprocal identities. So sine theta is equal to 1 over cosecant theta, just like cosecant theta equals 1 over sine theta. So it's just flipping. So these are all equivalent. So that's essentially what an identity is. It's writing something in the form of something else, but they both are equal. The quotient identity, so tangent is equal to sine divided by cosine. Cotangent is equal to cosine divided by sine. And then we have these Pythagorean identities. So sine squared of theta plus cosine squared of theta equals 1. 1 plus tangent squared of theta equals secant squared of theta. 1 plus cotangent squared of theta equals cosecant squared of theta. So these are all of the identities. We're going to use them to find other trig functions given, let's say, just one trig function. So the way in which we do that, we're going to try that out in this example. So let theta be an acute angle such that sine of theta equals 0.3. So here they don't give us a triangle, they just tell us that sine theta equals this value, 0.3. Find the values of A cosine and B tangent using the trig identities. So all we have is sine theta equals 0.3. And we want to find cosine theta and tangent theta. So if we go to our identities, let's look for one that either has just sine and cosine or just sine and tangent. So if you look through, so tangent equals sine over cosine. So we have sine, but we don't have cosine. So here we have sine and we want cosine. So since these are the only two identities used in this Pythagorean identity, we can use plugging in what we know for sine to solve for cosine. So we are going to use that identity, sine squared theta plus cosine squared theta equals 1. Because we know sine theta, and we just have to square it. So 0.3 squared plus cosine squared. So 0.3 squared, if we squared that, so here we get 0.09 plus cosine squared theta equals 1. Now I'm going to subtract 0.09 from both sides. So I get cosine squared theta equals 0.91. And my last step to find cosine theta, square root both sides. So cosine theta equals the square root of 0.91, which if you put that into your calculator, you get 0.95. So now that I have sine and cosine, let's go back to my fundamental trig identities, and we need to find tangent. So let's find something with tangent. So here's tangent, but we don't have secant. Here's tangent with sine and cosine. So since we have both sine and cosine, we could use this to solve for tangent theta. So tan theta equals sine theta over cosine theta. And we have sine theta is 0.3, cosine theta is 0.95. So that means that tangent theta would equal us dividing those. So if you divide 0.3 divided by 0.95, you get 0.32. And that is my tangent theta.